Okay, so you're asking about page 350, number 103. All right, the problem is in parentheses 2/3 m to the 13th power, n to the 8th power, close parentheses, and then parentheses again, 24 m to the 7th, n squared. Is it warm in here, or is it me? Okay, so welcome back, everyone. I guess we'll get our brains going again here. Yeah, you ready? Okay, so this was actually from the homework. Was it the homework before last time? Wasn't your homework last time off 355? Oh, it was the second. I gave you two. Oh, okay, sorry. All right, so it was from last time. All right, so first of all, when we're looking at these problems, remember we have the properties of exponents, right? It's very important to understand what the operation is between what's in the parentheses, what's happening in here. Is there addition, subtraction, multiplication? You know, what's going on? So we need to recognize that if they're just written next to each other like this with no plus or minus, it's implied multiplication. So there is actually like a little multiplication dot between each of those, and also on the other parentheses, same thing. And that's important because if there's multiplication, then you can use certain properties. If there's addition, then you have to use other properties. So first thing, can we do anything inside this parentheses? Can we put the m and n together? No, they're not the same base, so we can't put them together. Same with the other parentheses, you can't do anything in there. So what I'm going to try and do then is get rid of the parentheses. To do that, I have to understand what the operation is between here. So what's the operation between those parentheses? Multiplication. And I said if there's multiplication between parentheses, then you can just drop the parentheses, as long as there's not addition inside these. So this is all just a whole bunch of stuff being multiplied. So that's what I'm going to do. I'm going to write it out. It's 2/3 times m to the 13th times n to the 8th times 24 times m to the 7th times n squared. Now what I'm going to do is I'm going to put my numbers next to each other, my m's next to each other, my n's next to each other. So I get something like 2/3 times 24 times m to the 13th times m to the 7th times n to the 8th times n squared. And once I do that, I'm going to take care of these in groups. I'll have 3 groups here. So first, I have to multiply 2/3 times 24. If you do that on the side, that's the same as 2/3 times 24 over 1. And when we multiply fractions, we go straight across, right? So 48 over 3. And doesn't 3 go into 48? 16 times. Now you could have also, if you don't like multiplying fractions that way, if you want to do it this way, where you say, oh, look, that 3 here goes into 24, right? 3 goes into 3 one time. 3 goes into 24 8 times. And then if you multiply straight across, 2 times 8 is 16. 1 times 1 is 1. So you get 16 over 1, which is still 16. So either way, it's up to you. So the first part here is 16. And then we have a property. If we have m to a power times m to a power again, same base, what do we do with the powers? Add them. So this is m to the 20th. Okay, we have n to a power times n to a power again, same base, add the exponents, n to the 10th, and we're done. Did I address your question? Okay. Any others? Same page? Okay, 109. $25 h to the third j k to the fifth over 12 h squared k. All right, so same sort of approach that we just had. Let's look up on the top numerator, right? That's what we call that. Is there anything we can do up there? Can we put those together? No, I have h's, j's, and k's. I can't group those together. On the bottom, h's and k's, can't group those either. I can't do anything with the 12, right, through here? So top and bottom separately, you can't do anything. But how about if we look at them together? Well, you could look at this 25 as being divided by 12. The h cubed over the h squared separately. And then the k to the fifth over k to what power? On the bottom, if it's just k, what's the power? 1. And then we had a property. Did I hand out a property thing or no? I did not, right? Did I hand you all a sheet of properties? Okay, I wrote them out. So here, go back, see if I can get to our properties. No. Here was our first property, right? We add whenever we have same base and they're multiplied. And then if we have same base and they're divided, I subtract the top power minus the bottom power. So that's where I am here. So that's what I'll do on the h, that's what I'll do on the k. Now what about 25 divided by 12? Well, 25 over 12, is there anything that goes into both 25 and 12? No, right? That's a reduced fraction. You can't do anything to that. So I won't be able to touch the 25 over 12. So I'll just write down here equals 25 over 12. Now what about h cubed over h squared? That becomes h to the first power. Right now I'm going to write it out just so we see it. I'm doing 3 minus 2. And then times k to the what? 5 minus 1. Do y'all see that? The k, I take the 5, I subtract 1. What am I still missing here? The j, right? So I can put the j here on the end. Now, when I do 3 minus 2, what do I get? Just 1, right? So that's just an h. 5 minus 1, I get 4, and then I get j, right? Now, today we're going to talk about something that's important, and it's connected to this, so that's why I wrote it the way I wrote it. You see how I wrote this here? I did the number, then I did the h, then the k, and then the j. Now, the h became this, the k became this, and the j just stayed. My question is, are these h's, is this h, k, and j, are they in the numerator or are they in the denominator? So what's underneath every fraction? Like what's underneath, like 12 is the same as 12 over 1, right? Well, h is the same as h over 1. K to the fourth is the same as k to the fourth over 1. J is the same as j over 1. So you want to look at all three of these as being up in the numerator as opposed to down in the denominator. Today, we're going to have something else happen where sometimes they'll be down in the denominator. And there will be a way we'll be able to tell that, but just pay attention to it now. So I'm going to put 25. I'm going to put h, k to the fourth, j, over what? 12. I will also point out that the j here, if you look in the back of the book, it's probably in between the h and k. They just probably put it in alphabetical order. H, I, J, K. So, but it's okay to have it off to the side like that. All right. So from last class, let's see, what was the last property we had? I believe this was it right here. All right. Somebody check. We only have 3 properties. 4. Oh, there was one on a fraction too, right? Where was it? We have 5? Okay. Where was it? Okay, there's your 5th one right there. Okay. So we have 5 properties up to this point. And today we're gonna get a few more. All right. So let's call this property 6. So more properties. By the way, in the book we are starting 5.4. I'll put it to the left of this, 5.4. Sorry, it's off the page there, off the screen. More properties. Okay, what if you have something raised to the 0? It equals what? 1. Now, some of you have heard that before, and you just remember it, okay? Oh, anything to the 0 is 1. But I'd like to try and explain, give you some rationale as to why it is that way, okay? Let's try and show that this property is true with kind of an example on the side. What would 3 to the 3rd power be? Well, that's 3 times 3 times 3, isn't it? And that's 27. Do you agree? Okay, what is 3 squared? Well, that's just 3 times 3, which is 9, right? What's 3 to the 1st power? Well, that's just 3, isn't it? Agreed? Do y'all notice what's happening on my powers here? I started with 3, then 2, then 1, right? So the question would be, what's 3 to the 0? And I'm saying the answer is what? The answer is 1, right? Now, does it make sense that that would be the case? Look, when we started with 3 to the 3rd power, we were at 27, weren't we? Then 3 to the 2nd power, so the power came down, and what did we wind up getting? 9, which is really just 27 divided by 3, isn't it? And then to get from 9 down to the next answer, 3, 9 to 3, we divided by 3 again, didn't we? So for the next one down, we should divide 3 by 3 again, right? What's 3 divided by 3? It's 1. So it kind of makes sense that it would be a 1, doesn't it, kind of? Does that kind of make sense? All right, now, if we follow that pattern then, what do you think 3 to the negative 1 would be? Look, each time the power keeps coming down by 1, doesn't it? Started out at 3, 2, 1, 0. Now we're negative 1. Every time we did it, we divided by 3, right? Divide by 3, divide by 3, divide by 3. So when I take the 1, right, which is where we are, if I divide that by 3, what do I get? 1/3, right? 1 divided by 3. So I'm just going to write 1/3. What do you think 3 to the negative 2 would be then? Well, don't I divide that by 3 again? Right? So what's 1/3 divided by 3? It's the same as multiplying it by the reciprocal. In other words, you get another 3 on the bottom. So what would 1/3 times 1/3 be? 1/9, right? I'm going to write it this way, though. 1 over 3 squared, which is 1/9. What do you think 3 to the negative 3 would be? 1/3. 1 over 3 to what power? How many 3's are we going to have on the bottom, do you think? We had 1 3 down here, right? When we put negative 2, we had 2 3's. We go negative 3, we should have how many? 3 3's being multiplied. 3 times 3 times 3, 1 over 27. You kind of follow that? That leads us directly to our next property. I want you to focus all your attention right now on these last 3 that I did. I'm going to write this in red. See the little red I put here, that 1? See over here this 2 right there? See this 3 right here in red? See that? So look at this. When I say 3 to the negative 1, don't I just write 1 over 3 to the positive 1? When I write 3 to the negative 2, don't I just write 1 over 3 to the positive 2? When I write 3 to the negative 3, don't I write 1 over 3 to the positive 3? So when I write 3 to a negative power, what happens is I make it 1 over 3 to whatever that power was, but positive. Are you following that? Let me see. If I wrote 3 to the negative 10, that would be what? 1 over 3 to the positive 10. Okay? Now, you would have to go on your calculator 3 times 3 times 3 10 times, which I don't want to do, but that's the idea, right? So what do you think the property says here? If you have b to the negative n, that should be equal to what? 1 over b to the positive n. Good. So these are our 6th and 7th properties, respectively. All right? Now, I do need to point something out here, although I'm not going to get too deep into it. This b to the 0 equals 1 does not work if b is 0, okay? So this property only works if that b isn't 0. If I try and write down what's 0 to the 0, that is not 1. It's not 0 either. It's what we call undefined. It's messy. You don't mess with that. It's kind of like trying to divide by 0. It's not allowed. Okay. I don't want to say anything else about that because I don't want to confuse you. All right. Anytime we have something to the 0, it's 1. Anytime we have something to a negative power, we turn it into a fraction 1 over it. So you can almost look at it like it drops to the bottom, like it drops as a denominator. All right? It's raining. My 5-year-old daughter's having a field trip today. I'm like, it's inside somewhere. I don't know. No, it's children's baking something in Stonegate Hill or Stonegate area, or wait, not Stonegate. I don't even know out there. 1604 near Stone Oak area. Yeah, Stone Oak. It's like they go in and they learn how to like bake or something, whatever. Well, she always likes to bake. Okay, those are our properties. Let's see them in action. All right, let's give you some examples here. Now, what's going to be a little bit challenging, I think, for you today is that you have to remember all the other 5 properties that we had before we walked into class. So everything is going to get combined here today, and by the end of this section, we will have all the techniques, all the different properties that we need to work with stuff where we're headed, okay? So let's start off. Okay, let's do these. Some examples. What would negative 5x to the 0 be? Well, what do you think? 1. That's it, right? See, the thing is, what's happening in here doesn't really matter, right? That's kind of like our b. And we have b to a 0, right? b to the 0 is 1. So this is just 1. All right, next example. How about negative p to the negative 3? So I'd like for you to simplify that. Now, there's a general rule of thumb, okay? Whenever you're looking at a problem and you're asked to simplify, the rule of thumb is to never leave your answer with a negative exponent. Don't ever leave something with a negative up there as a power. Always try and make it a positive. Well, our property says that if we have something to a negative, what do we do with it? We drop it down, right? We write 1 over that to the positive power, right? What about the negative in front of the p? Is that negative, well, I should say, is the negative 3 acting on the negative out in front of the p? No, because it's not in parentheses, right? So we want to look at this as being really like a negative 1 times p to the negative 3, right? You'll see that? And then how can I rewrite p to the negative 3 as what? Use the property 7. How do I rewrite this? 1 over p to the positive p, right? The property, what it does is it allows you to rewrite this so it doesn't have a negative anymore. What you have to give up, though, is you have to put it in the bottom as a denominator. All right, now one more thing. I'm going to multiply this. This negative 1 out here is really like a negative 1 over 1, isn't it? So multiply straight across. What do you get on top? Negative 1 over p to the third. That's it. So negative p to the negative 3 is the same as negative 1 over p cubed. How about this? What's negative 2 to the negative 2? So look inside the parentheses. Is there anything you can do inside the parentheses? Negative 2 is just negative 2, right? Now the negative 2 as the exponent, is it acting on the negative sign here? Yes, because it's in parentheses, right? Yeah? Okay, so I'm going to rewrite this. Let's try and get rid of that negative power out here. So I'm going to write 1 over, right? And then what's the b for us in this problem? What's the thing being raised to a power? What is it? Negative 2, right? Should I write it in parentheses? Yes, because now I'm going to put what power on it? Positive 2. You follow? So again, this was like our b to the negative 2 became 1 over b to the positive 2. Now, what is negative 2 to the 2? What does that mean? What's negative 2? That's negative 2 times negative 2, isn't it? To square something? So this means 1 over negative 2 times negative 2, which is positive 4, isn't it? Okay, good. Positive 4. So 1 over 4, 1/4. So negative 2 to the negative 2 is just 1/4. It's just a real weird way of writing 1/4. Okay. Let me see if you're ready for this or not. How about 5x squared y to the negative 3 all to the negative 3? Look in the parentheses. Can you do anything in here? No, right? Well, how about that negative 3 on the y? Right here. Not out here yet, just this right here. Can you rewrite y to the negative 3 as something? 1 over y to the positive 3, right? Couldn't you? Now, you could do that right now if you wanted to. That wouldn't be wrong, but this is the way I'm going to approach it. Go back to last class real quick. That last property we had, where is it? Oh, no, it was property 4. There we go. Remember this property? It said if we had two things in parentheses and they were being multiplied, it was important that they were being multiplied. I think I pointed that out at the end of class too. If these two are multiplied and we have a power out here, that power just goes to each one of them, doesn't it? So I'm going to use that property, which is going to be property 4. Whoa, yeah. Property 4. So I'm going to use property 4. I'm going to circle it here to tell you what I'm about to use. And what I'm going to do is this. I'm going to take all 3 factors that are in here, and I'm going to raise each of those 3 factors to the -3. Okay, so that -3 is going to be applied to each one of those. So I will have my 5 raised to the -3. I will have my x squared raised to the -3. And then I will have my y to the -3 raised to the what? -3. Do y'all see that property in action there? Now let's try and do each one of these. 5 to the -3. Let's use property 7 here. By property 7, what happens? What does that become? 1 over 5 to the +3, right? Okay, on this next one, what can we do? What is something to a power to a power? What do you do here? You multiply the powers, don't you? What property was that? Let's go back and look in our notes from last time. We had something to a power to a power. Nope. There it is, property 3. The power rule. Something to a power, you multiply the powers. So by property 3, that becomes what? X to what? What's 2 times -3? -6. Okay, times, now what can I use for this one over here? The last one. What property? Same property, right? Property 3 again. That would be y to what power? +9, because -3 times -3 is +9. Okay. Everyone still there? All right. 1 over 5 cubed means you have to do 5 times 5 times 5 on your calculator, which gives you 1 over 125. Okay? Now, x to the -6, we said we don't like to leave things with negative exponents. X to the -6 will become what? 1 over x to the +6, and that's property 7, isn't it? So property 7 is going to take us down to 1 over x to the +6 times, now y to the 9th is just y to the 9th, right? We're happy with that? And y to the 9th will actually appear by itself like this. Now I'm ready for a final answer. What things go in the numerator? Which of these things what's on top, what's on bottom? That's what we have to figure out. So this 1 is obviously on top. This 1's on top. The y to the 9th, top or bottom? It's on the top, right? Because there's a 1 underneath it. So we have just a y to the 9th on top, right? On the bottom, what do we have? 125 and x to the 6th. And we're done. Why are we done? Well, we don't have any more parentheses, right? We don't have any negative exponents. All of our numbers that are raised to powers have been multiplied out, 125 for 5 cubed. Yes. Okay. Okay, so if you look at this right here, right, that's the same as y to the 9th over 1. Agreed? So if this is a fraction times a fraction times a fraction. If you multiply straight across, you get 1 times 1, which is 1. 1 times y to the 9th is y to the 9th, so that goes here. Then on the bottom, 125 times x to the 6th is 125x to the 6th times 1, which is the same thing. So you're just going straight across getting the y to the 9th, straight across getting this. Does that make sense? Okay. Any other questions? Okay, what I'd like to do here, let's see if I can find a marker that works good. This one's pretty good. Let's just write the properties out real quick. See where would be best for everyone. You have them in your notes, but I'll put some of them over here and then some of them over there. The first property we had, and someone can check, it was b to the n times b to the m was b to the n plus m, right? Second one, b to the n over b to the m was b to the n minus m. Third one, b to the n to the m was b to the nm. Fourth property, I think, was that one, a times b is that the fourth? Yeah. And was it m or n? M, as in Mike, is a to the m, b to the m. And then, what was 5? Oh, a divided by b, I forgot, yeah. So the fifth one is a over b to the m, a to the m over b to the m. Then we just got the sixth one, which was b to the 0 is 1. And the seventh is b to the negative n is 1 over b to the positive n. Now the book kind of stops right there when it comes to properties. All right, that's where they stop. But I've got a few more that I think are helpful. All right? Got 2 more. So this will be property 8 and property 9. Property 8. What if you have 1 over b to the negative n? Now I want you to compare that to property 7. On property 7, we had b to the n, negative n, didn't we? This one, where's the b to the negative n? On the top or the bottom? It's on the bottom. Here we could say the b to the negative n was on the top, right? And then we put it as a 1 over it. So it went from the top to the bottom, didn't it? What do you think is going to happen if it's on the bottom? It's going to go to the top. But when it goes to the top, what happens to the power? Instead of being negative, it'll be positive. So what we want to write here is that this is b to the positive n. See, the book doesn't talk about this. Let me just try and explain what I'm trying to get you to see. If you have a negative power on the top, it drops down and becomes a positive power, right? But what if you have a negative power on the bottom? It goes up and becomes positive. So it's just extending what they've already shown you. Negative power on top drops down, negative power on the bottom goes up. And then the 9th property. Okay, what if you have a fraction raised to a negative power? Let's see if we can deduce what would happen. Well, the negative power, what happens when you have a fraction in general? Look at property 5. When you have a fraction to a power, doesn't that power go to just the top one and the bottom separately? Doesn't it? So that negative n should go to the top and the negative n should go to the bottom, shouldn't it? Yes? Now don't write this down, but this is what we're saying it should be, a to the negative n and then b to the negative n like that. If we're following property 5, that's what would happen, right? Okay, but if you have a to the negative n, so if you have a to a negative power, what do we say happens if something's on top with a negative power? Where does it go? It drops to the bottom and becomes positive, doesn't it? So this is going to become a to the positive n here, but what about the b to the negative n that was on the bottom? It goes to the top, right? And the power becomes positive. But isn't that the same as b over a to the n? Just look at that. If I go b over a and I say to the n would go to each one, wouldn't it? And that's exactly what that's saying, right? So I want you to just look from here to here instead now. Forget all the crap we did in the middle. What is this property saying? If you have a fraction to a negative exponent, what do? You flip the fraction over and you make it a positive exponent. That's the property I want you to be able to use. Okay? Property 9 says a fraction to a negative power, flip the fraction over, change it to a positive power. If you want to know why it works, look at everything I did in the middle. Yeah, I don't believe that's in your book. Okay. Let's try something. Another example. God, you didn't realize today was going to be this good, huh? You had no idea coming into class today. Man, the properties of exponents are going to be awesome. What about negative 1 half to the negative 4? What would you like to do, folks? You want to flip it? So you want to use property what? 9? Okay. Can you all see these up here? Well, you can. You're right here. In the back, can you all see these all right? What was 8? 1 over b to the negative n was b to the n, and then 9th was a over b to the negative n. Remember, you're allowed to have cheat sheets on the test. I would have all these on that cheat sheet. Okay, so what property? Someone said flip it, right? Who said flip it? Flip it? Flip it? No one wants to say. Flip it? Okay, if we're going to flip this, then what property are you using for that? 9, right? 9 says if we have a fraction to a negative power, we can flip it. So, okay, I'm going to flip it. When I flip it, what goes on top, what goes on bottom? 2 on top, what on bottom? You want negative 1? So you're going to look at that negative as it was on the top. Remember, negatives on fractions are either on the top of the bottom or out in front. It's your choice. I'm going to say that negative 1 was on the top. So when I flip it, it becomes 2 over negative 1. And then to the positive 4 power. Can you figure out what 2 over negative 1 is? What's 2 divided by negative 1? Negative 2, right? Oh, to the 4th power? Is that 4 acting on the negative here? Yes. Because I kept the parentheses the whole time, right? You need to make sure you keep the parentheses the whole time also. What's negative 2 to the 4th power? That's negative 2 times negative 2 times negative 2 times negative 2, positive 16. I've been wanting to do this, like for my entire life. I've been waiting for this moment, waiting for like my daughter to turn like 16 or some nice number like this. And you know, like on cakes, you can go to like HEB and get those little wax candles that say like 1 and then 6, right? I want to go and like get wax candle and somehow like make my own like negative 1 half, like somehow with some wax parentheses or something, and then put like a negative 4 power on it, and everyone will be like, "What the hell is that?" That's how old I'm 16 today, right? Yeah, she's in trouble, huh? But that, I mean, that is a fancy way of writing the number 16. It's just another way of writing it. Sorry. I'll do that like if I go to, yeah, I've got a lot of time. I might change my mind. I'll go to like HEB's deli or something to order like a quarter pound of ham or something like that, right? And I'll just go and I'll say like something like that. I'll be like, how much do you want? And I'll be like 2 to the negative 2. What? 2 to the negative 2 is the same as 1 over 2 squared, which is the same as 1/4. So that's quarter pound, right? Just to see reactions. Or I'll do something like, just simple fraction addition. I'll take like 1/8 plus 1/8, and they'll be like, Depends on my mood. That's not fun, right? Man. See, I don't worry so much about them being out there as much as I worry about the drive there and back. Right? God, being a parent sucks, man. I should have. Well, the thing was, they canceled it last week for some reason, and they redid it. So my plan was to try and go, but okay. Speaking of wax candles and dorky stuff, math dorky stuff, I'll share a story with you. Since it's Monday, no one seems too excited about this. And I'll pause it because this really isn't. Some subtle differences in the way things are written. Actually, I might do 4 examples side by side. Yeah, let's do this. Okay, let's look at this one. How about 4x to the negative, to the negative 3. Next to that, here's another one. How about negative 4x to the negative 3? Next to that, how about 4x to the negative 3? And how about next to that, negative 4x to the negative 3? Okay, all 4 of these problems are going to turn out to have different answers. And what I'm trying to show you in this is how the use of parentheses and everything works, and make sure we're real clear on it. So let's work each one of these. So let's start with the first one. You tell me, what property would you like to use here? There's more than one correct answer for properties. Which property looks the best to you here? Because, I mean, when it comes down to it, I can do this, right? I can show you how to do this, and that's fine. Following me through it is going to be easy. You doing it, that's different. So what can you do to this one? We'll call this A, we'll call this B, we'll call this C, we'll call this D. Can you just leave it like that? No, because I've told you that to be correctly simplified, you can't have a negative exponent, which I have right now. Any ideas? Property 4. Do y'all see property 4 here? Property 4 says if I have 2 things in parentheses being multiplied and I have a power, that power can go to each one. What do y'all think of that? That seem reasonable? I have 2 things inside of parentheses. I have a power. Yeah, I'm okay with that. That's actually exactly what I would have done. So I'm going to go and I'm going to take each of the things inside, the 4 and the x, and I'm going to raise each of them to the what? Negative 3? Negative 3, right? Y'all see that property 4? Okay, now what about each of these? What property? What property will let me work this one out here? Property 7 says if I have something to a negative power, I put 1 over it to a positive power, right? So I can turn that into, by property 7, I can turn that into 1 over what? 4 to the positive 3. Then what about the next one? I'm going to put a times in between that. What about x to the negative 3? 1 over x to the positive 3. Same property, isn't it? Property 7 again. And at this point, we have positive powers, don't we? We just need to put these together. So these are being multiplied, so multiply straight across. What's 1 times 1? 1. Hey, 4 cubed. 4 times 4 times 4. 64. And then x cubed, that's just x cubed. And we are done. See that? Okay, what about this problem here? Problem B. Same thing, right? What's the only difference we're going to have? When we use that property 4, we're going to have two things, right? Each of those is going to be raised to the negative 3 power. What goes in the first parentheses? Negative 4 instead of positive 4. And then the other parentheses is x. So the key was to see the negative is going to come with the 4, right? The negative is going to come with the 4 because it's in the parentheses with it, isn't it? Now, you want to use property 7 again on both of those? Okay, so here and here, property 7, property 7. What is that? What does the first one become? What's negative 4 to the negative 3 become? 1 over negative 4, right? To the positive 3. The only thing that changes is the power goes from negative to positive, right? The negative 4 does not change to positive 4. Just the power changes positive. And then what about the x? 1 over x cubed. Okay, let's figure out what negative 4 cubed is. That's negative 4 times negative 4 times negative 4. Negative, negative, negative is going to be negative still, right? So we have instead of positive 64, we have negative 64. And then over here we have 1 over x cubed. Multiply straight across 1 over negative 64x cubed. Box it up. How about the next one? Help me out. What's that? Property 7, you have something to a negative power, do 1 over it to a positive power. What is the something that you're going to be putting property 7 on? Just the x. Just the x. Look, that negative 3 is only acting on the x. Why is it not acting on the 4? There's no parentheses, right? So this is really just a 4 times, what does the x to the negative 3 become because of property 7? 1 over x to the third, right? That 4 is just sitting in front. Now that 4 is the same as 4 divided by what? 1. And now multiply straight across, you get 4 over x cubed. And that's done. See the difference there? What about the last one? Same thing, except that instead of having a 4, we have a what? A negative 4. So we leave the negative 4 out front. We change the the x to negative 3 to 1 over x cubed. This is the same as negative 4 over 1 times 1 over x cubed. And this is negative 4 over x cubed. And that was also property 7 that took us there. Look, all these problems had the same thing. They all had a 4, an x, and a third power, negative third power. But because of uses of parentheses and negative signs, they all gave us different answers. You have to get to a point where you are completely comfortable with all of this, right? All these properties. I'm going to go to a new page. Let's practice a couple of other things. What's x to the negative 6 over y to the 4th z to the negative 8? All right, in the numerator, top. Can't do anything up there as far as combining anything. There's only one thing up there, right? Bottom, y's and z's can't be grouped together, can't be combined. So top and bottom, as they are, can't really put them together. We can't just box this as our answer because we've been told we cannot leave things with negative exponents. So let's try and resolve the negative exponents. What can I do with the x to negative 6? Use property 7, which says if I have a negative power, I can drop it to the bottom, right? So x to the negative 6 will drop to the bottom as an x to the what? Positive 6. Then what about in the bottom? Y to the 4th is fine, isn't it? But z to the negative 8 is negative. It's on the bottom, so where does it go? Up to the top. So what's happened is my x's and my x and z's are going to switch places, and then each of the exponents will become positive. So on top, what do I have? Z to the 8th on the bottom, y to the 4th, x to the 6th. Now we are okay. How about this one? X to the 7th, x to the negative 4 over x to the 20. Now you have options here, so I'd like to see who wants to volunteer which property they want to do here. By the way, the one on top, we just use property 7, right? Multiple times. Just so you know, that's what we use there, property 7. And 8, actually. Excuse me? What question? What? Here? Okay, you want to use property 1 on the top? We can do that. Everyone agree that that's okay? All right, I agree. So what would it become? According to this, I add those two powers, right? I do 7 plus negative 4. I'm doing x to the 7. I'm adding to it negative 4, which same as subtracting. So the top becomes x to what power? Third over x to the 20th. Okay, something is about to happen. I want to see what you do here. What property now? That was property 1, right? Don't I what? What property can I use on this? Property 2. 2 says I'm supposed to take the power on the top, right? And subtract the power on the bottom. So this will become x to the 3 take away 20, right? What's 3 minus 20? Negative 17. So that was property 2 that took me from here to here, right? From this step to this step, that was property 2. 3 minus 20 is negative 17. Can I box that? No, because it's a negative power. So I need to rewrite it with a positive power. So I use property 7 to do that. Property 7 makes me write it as 1 over x to the 17. Now I can box it. Is this painful or? We have about 2 or 3 more examples. And they're going to get a little harder as we go. Okay, next one. What's x to the negative 3, y to the 7th, z over x to the negative 7, x squared, y to the 3rd, z to the negative 2. Do what? Okay, so you want to go and you notice on the bottom you have x's here. You want to put those together first? Is that okay with everyone? Okay, that's fine with me. And to do that, I'll be using what property? To put those two things together, I'll be using property 1, right? So property 1 is going to get me from here to the next one. Now, I'm not doing anything to the top, just leaving it alone. Now, property 1 says I add those exponents, right? What's negative 7 plus 2? Negative 5. Then I have y to the third. Then I have z to the negative 2. All right, I like that. That's good. Now, you want to use property 7. See, you have there's multiple correct ways to go here. It's all how you want to do it. So let's look at, there's really on this one, there's kind of two trains of thought. One thought would be, everywhere you see a negative exponent, drop it down, or if it's on the bottom, do what? Take it up. You could do it that way. Or you could do it this way. I've got x's here, I've got y's here, I've got z's here, and I could use property 2. Either way. So let's do a quick vote. How many of you want to take all your negative exponents on top and drop them to the bottom, all negative exponents on the bottom and bring them up? How many of you think you would feel better doing it that way? Only one? Really? Okay. No, it's okay. I mean, I actually think that's the safer bet because of what you have to do for property 2. For property 2, all you have to do is subtract the powers, right? Well, let's see how you do that. I'm going to do it the other way, which is leave it like this, using property 2. Let's just make sure we get all our signs right. This equals by property 2. What is x to the negative 3 over x to the negative 5? According to property 2, it's x to the negative 3, right? X to the negative 3, and then I'm supposed to subtract the power on the bottom. So I subtract what? Negative 5. See, you're subtracting a negative. Then I have y to the 7 what? Minus 3. Now that's not, we don't have to worry about signs too much there. And then z to the what? 1 take away what? Negative 2. So my question would be, are you going to be okay with these signs? Because you have like double negatives there. They will, yes. So remember that when you subtract a negative, that's the same as adding. So this becomes negative 3 plus 5. This one is just 4, 7 minus 3. This one is the same as 1 plus 2. So what do we get? X to the second, y to the fourth, z cubed. And all of them live up on top, right? There is nothing on the bottom. So I just box it up and I'm done. Questions? Now I'm curious, would it have gone quicker the other way? Or would it have been better? Do y'all want to see it the other way? I'll do it right here. I'll just take these out. If I were to have done it the other way, what stays on top? What's going to stay? Because I'm going to move the x to negative 3 down, right? So I know I have a y to the 7th, a z, right? What stays on the bottom? Just the y to the 3rd, right? Okay. Now what came down to the bottom from the top? X cubed, right? That x cubed came down. What comes up from the bottom? X to the 5th. What else? Z to the 2nd. Y'all see what I did? Everywhere I had a negative exponent, I dropped it down. If it was already on the bottom, I brought it up. Now what could you do here? How about z and z squared together? That would become what? Z cubed, which is this. What about y to the 7th over y cubed? Subtract 7 minus 3 is 4. So you get y to the 4th. You would also have x to the 5th over x cubed. 5 minus 3 is 2. The only thing, I guess the advantage of doing it this way is when you do that property 2 and you do subtraction, it's always nice numbers. You're not doing like negative, negative. It'll always be better. So you pick your own way, all right? All right, we're getting close to the grand finale here. Two p to negative 4 q q to the third over 5 p squared q, all of this to the negative 2. Well, what would you like? Skip it? Call it a day, right? Let's just look inside the parentheses. On the top, can I put any of that together? No. Bottom, anything? No? Okay. I do have some negative exponents, don't I? I could bring that down as a p to the fourth. I also have p's on the top and bottom and q's on the top and bottom, so I could use property 2. Right? All of that seem fair? But I can also do something else. I have a negative exponent on a fraction. And property 9 says if I have a negative exponent on a fraction, I can flip the whole fraction over and make it a positive exponent. So if I wanted to, I could just flip this whole damn thing over and make it a positive 2. You want to do that? Why, just because it seems fun to do all that? Yeah? It's not wrong, right? Okay, so I'm going to use property 9 and flip it. Now, when I flip it, nothing changes, right? If it was negative, it stays negative. So on the top, I have 5p squared q. On the bottom, I have 2p to the negative 4 q cubed. Property 9 says the fraction stays exactly the same, but it's flipped. The only thing that changes is the negative exponent becomes positive. Now what? You want to do property 2 on the p's and q's? Have you all ever heard that? Mind your p's and q's? Is that correct? What does that stand for? Do you know? I don't know either. Is it mind your p's and q's? Be on your p's and? All right. Let's finish the problem, then we'll figure out what that means, okay? What is p squared over p to the negative 4? So watch, I still have my big parentheses. I still have 2 out here. That's going to be p to the 2 take away what? Negative 4. Do you want to do the q's at the same time here? It would be q to the what? 1 minus 3. And what about the 5 over 2? Can't do anything with it, right? So can I just leave it as a 5 over 2 out here? Okay, do you see the 3 things I have? 1, 2, 3. So what is 5 halves stays? What's p to the 2 minus negative 4? That's 6, right? 2, because that's really 2 plus 4. So p to the 6. And then q to what power? Negative 2. All of this what? Squared? Everyone okay with that? All right. We're not done. Go ahead and tell me what property you want to use, what you want to do here. As long as it's a legal algebraic move, I'll do it. You want to do property 4? Okay, good. I like that one. Property 4 says if I have things being multiplied inside and a power on the outside, the power can go to each one. How many things do I have on the inside? 3. 1, 2, 3. And I'm going to apply a square to each one of them. So this is going to be by property 4. By the way, coming here, this was property 2 and property 2 that I used. So property 4, I'm going to have my 5 over 2. I'm going to square that. I'm going to have my p to the 6. I'm going to square that. I'm going to have q to the negative 2. I'm going to square that. What's 5 over 2 squared? Well, you don't need a calculator. What's 5 over 2 times 5 over 2? Oh, sorry, that's off the page. You multiply straight across. 5 times 5? 25 over 4. 25 over 4. What's p to the 6th squared? P to the 12th. What property are we using? Property 3. Something to a power, you multiply the powers. So that's p to the 12th. That was property 3. What about q to the negative 2 to the 2? That's q to the what? Negative 4. And that again was property 3. Are we done? No, because I have a negative on the q. Where is that q? Is it on the top or bottom right now? It's on the top, so it's going to drop down to the bottom, isn't it? What's also on the bottom? A 4. So what are the things that are on the top? 25, p to the 12th, and on the bottom, a 4 and a q to the 4th power, and we are done. I'm sorry I didn't give you any time today to work in groups on this. I don't think we really have enough time right now. I will get the attendance. Give me a second. Let me first put the homework assignment up, and then I'll cut you loose. All right. So 13, 17. Oh, yeah, page 364. 27. 35. 39. 40. 45. All right, that's the beginning. Sorry. 51 through 91, odd. So here's really the main part of this assignment, all right? If you feel pretty good about yourself right now, what we did today is kind of making sense, then just start at 51, do 51 through 91. If you feel like you're really going to need to kind of take it step by step here, do these problems first. That'll kind of build you up to those. Numbers 51 through 91, they get progressively harder and harder and harder. Let's plan for a quiz on Wednesday over your homework. You'll be allowed to use your homework on the quiz. Do not do your homework in your notebook. In other words, if you go home and you do your homework in your notebook, then you come to take the quiz and I say you can use your homework, you're like, well, it's right here on the back of my notes. You can't use anything. All right, so you do your homework separate for this one assignment at least. All right? Any questions? All right, let me just call attendance real quick and then you can go. By the way, the last day to drop a class is next Monday. At least that's what I've got written down here. Last day to drop a class is Monday, April 21st.